Would you like to know on how to draw ionic bond, covalent bond, and dative bond by using Lewis dot symbol? Let's watch the video. This is to show you on how to draw Lewis diagram or Lewis dot symbol for sodium chloride. Sodium chloride is an ionic compound. So in this case, we are going to draw the formations of the ionic bonding in sodium chloride. Firstly, you have to write the electronic configurations of the sodium in order to know its valence electron. So from here, we have one valence electron in sodium. So sodium will lose this one valence electron to form Na plus ion. In this ionic configuration, this ion has achieved stability of noble gas configuration. Meanwhile, for the chlorine has 7 valence electrons. So in order to achieve stable octet configuration, chlorine atom has to receive 1 electron from the sodium to form this valence configuration. Now, this ionic valence configuration has achieved stability of noble gas configuration or octet configuration. So now, by having these informations of these valence electrons for respective metal and non-metal, we will draw the Lewis dot symbol for these two elements. So sodium has 1 valence electron, so you have to draw as sodium dot. 1 dot represent 1 electron, plus with chlorine that has 7 valence electrons. So what happens next is 1 electron from the sodium will be transferred to the chlorine. So this will form Na plus ion for the sodium. And chlorine will has 7 plus 1 electron from the sodium just now. It will form an ion Cl minus. So by having this plus charge and negative charge here, so the attraction forces between these two that forming ionic bonding. So in this case, you can also check the bilangan of the atom to write for metal and non-metal, okay, from this formula. So sodium is from group 1, so it will form plus 1, it has plus 1 charge. And chlorine from group 17 will has negative 1 charge. So bila you darab silang, you akan dapat formula of this ionic compound. So this information menunjukkan bahawa, okay, in drawing your Lewis dot symbol, you just need to have satu sodium atom sahaja di sini, okay, dan juga satu chlorine atom sahaja di bahagian sini. Alright, so after forming this ionic bonding, you can check the charge as well. Sodium plus has plus 1 charge, Cl minus has negative 1 charge. So the total between these two values akan bersamaan dengan kosong. So this total charge kosong ini adalah konsisten dengan charge di atas NaCl tersebut. So since NaCl is a neutral compound, so the total charge of the ion must equals to 0 as well. Next, we will see the Lewis dot symbol for sodium oxide. So in the sodium oxide, we have sodium and oxygen. Sodium is from group 1, so the charge will be plus 1. Oxygen will be from group 16 and the charge is negative 2. So bila kita darab silang between these two, kita akan dapat this formula Na2O. So from this formula, you can see that we have sebanyak 2 sodium atom dan 1 atom of oxygen. So in order to draw Lewis dot symbol for this ionic compound, you must make sure to draw sebanyak 2 sodium atom dan 1 oxygen atom. So firstly, starts by writing the electronic configuration for the respective element. So again, sodium is in group 1, so this will be the valence electron of the sodium. And then what happened is sodium will lose 1 electron okay, to form the new cation Na+ with this octet configuration of the new cation here. And for oxygen, oxygen has 6 valence electrons. In order to achieve stable octet configuration, oxygen needs to receive sebanyak 2 electron. So from there, you can proceed by drawing the Lewis dot symbol for sodium oxide. So again, just now you dah identify we need to draw sebanyak 2 sodium atom. Okay, so now we have 2 sodium atoms. Okay, with respective 1 valence electron here. And then add with oxygen atom with 6 valence electrons. So what happens will be 1 electron from 1 sodium transfer to oxygen. Dan juga 1 lagi electron will transfer to the same oxygen. This will form Na hilang 1 electron becoming Na+. So bila ada 2 sodium atom yang hilang sebanyak 1 elektron setiap satunya, so you kena ada 2 di hadapan. So 2 Na+. And for the oxygen, it has 6 electrons yang asal, tambah 2 from the sodium just now, so the ion will become 2-. So the attraction forces between these two opposite ions, ini yang kita panggil sebagai ionic bonding. And you can check from this diagram. So since sodium dah pun kehilangan sebanyak 1 electron from here, okay, dia dah mencapai stability of octet configuration. So kita tak tulislah any electron dekat sini. Okay, this is to show that sodium sudah pun kehilangan 1 electron just now. So we will put the positive charge over here. And for the oxygen, since oxygen receive another 2 electron, so kita akan tulis ke semua elektron untuk oxygen di dalam diagram ini. So daripada 6 electron here, receive 2 electron. Okay, so total electron pada valence yang terbaru adalah 8. So you should write sebanyak 8 electrons juga di sini. And from here also you can check the charge of these ions. So untuk sodium kita ada 2 darab dengan 1, so plus 2 untuk cation, and for anion kita ada negative 2. So hasil tambah between these two ions adalah bersamaan dengan kosong. So this nilai 0 juga adalah konsisten dengan total charge untuk this ionic compound. These are the properties of ionic compound. They are solid at room temperature. They have high melting and boiling point. They are soluble in water. And in the molten form, they can conduct electricity because they contain mobile ions, that is cation and anion. Okay, in molten maksudnya dalam keadaan lebur. Bila kita panaskan this solid ionic compound, okay, compound itu akan menjadi lebur. So dalam keadaan lebur, maka kita akan ada cation dan anions yang mobile, maksudnya boleh bergerak in the entire space of the compound. So with the presence of these free moving ions, ini yang menyebabkan molten ionic compounds can conduct electricity. These are the properties of ionic or electrovalent compound. So ionic compound are solid at room temperature. They have high melting and boiling point. They can soluble in water, boleh larut dalam air. And in molten form, they can conduct electricity because they contain mobile ions, okay, that are cations and anions. So dalam keadaan lebur, okay, ionic compound boleh mengalirkan electricity, okay, boleh conduct electricity. Kenapa? Due to the presence of mobile ions, cation and anion. Sebab kita ada ion yang bergerak. Mobile ions means ions yang boleh bergerak. Covalent bond is formed when atoms sharing their valence electrons in order to achieve stability of noble gas configuration, or it is also said as to obey octet rule. So in order to form covalent bond, it will involve non-metal elements, and these non-metal elements will share a pair of electrons to form a covalent bonding. So one covalent bonding has 2 electrons. And we can have single, double or triple covalent bondings, and it can be represented by using single dash for single bonding, okay, double lines for double bonding, and the 3 lines here to represent triple covalent bond. So here hydrogen has 1 valence electron, and this hydrogen is not yet achieved stability. So in order to achieve stability, so apa yang berlaku adalah this hydrogen will share its valence electron with another hydrogen atom. So by doing this, now kita dah ada 2 elektron di tengah-tengah di antara 2 hydrogen atom. Okay, so this kind of drawing menunjukkan bahawa these 2 electrons are being shared between these 2 hydrogen atoms. So this is the electron dot symbol for the formation of this covalent bonding. We can also represent this structure dengan menggunakan Lewis structure. So di sini kita akan lukis hydrogen. So here are the 2 electrons shared between 2 hydrogen atoms. Kita lukis sebagai single dash to show that this is single covalent bonding. So single covalent bonding ini mengandungi sebanyak 2 elektron, sama seperti di dalam electron dot symbol over here. So by sharing electrons, kita boleh nampak bahawa hydrogen ini telah mempunyai sebanyak 2 elektron, and this hydrogen as well sudah pun mempunyai sebanyak 2 elektron. So here both hydrogen atoms ini telah pun mencapai stability. Stability jenis apa? Doublet stability. And then for bromine atom, so bromine here has 7 valence electrons. So bromine needs another 1 electron in order to achieve octet stability, iaitu sebanyak 8 elektron. So apa yang akan berlaku adalah this bromine atom will share its valence electron dengan another bromine atom. So by doing this, you can see in this electron dot symbol, so here will be the 2 electrons shared by 2 bromine atoms. Okay, so ini adalah bentuk Lewis dot symbol. Okay, to represent in the form of Lewis structure. So bonding yang dikongsi di sini kita boleh symbolizekan dengan menggunakan single lines. Okay, so BR 1 dash to represent bonding over here. Okay, electron shared di tengah itu, dan juga bromine atom lagi 1. Okay, and pastikan you lukis all the electrons remaining dalam setiap satu bromine atom. So di sini we can see that this bromine now telah pun mencapai octet stability. Okay, kenapa octet? So satu bonding here represent sebanyak 2 elektron. So 2, 4, 6, 8. So this bromine has achieved octet stability, and for this bromine as well telah mencapai sebanyak 2, 4, 6, 8 elektron. So this bromine juga telah pun mencapai octet stability. Okay, so electrons yang berada di sekitar atom ini kita panggil sebagai lone pair electrons, and these lone pair electrons does not involve in the bonding. Okay, so nama lain dia adalah non-bonding electrons. And the electrons that involve in the bonding, of course lah kita panggil sebagai bonding electrons. So yang ini pun kita panggil sebagai lone pair electrons ataupun non-bonding electron. Okay, dan yang di sini kita panggil sebagai bonding electrons. So here we have 2 oxygen atoms. So in one oxygen atom, it has 6 valence electron. So in order to achieve stable octet configuration or octet stability, this oxygen atom needs another 2 electrons. They need to receive, okay, or they need to share another 2 electrons in order to achieve octet stability, iaitu mempunyai sebanyak 8 elektron. So the first oxygen akan use its 2 valence electron to be shared with another oxygen. So the other oxygen pun masih memerlukan lagi sebanyak 2 elektron. So the next oxygen juga akan menggunakan sebanyak 2 valence electron untuk dikongsi bersama dengan oksigen yang lagi satu. So kita akan nampak ada berlakunya sharing of 2 pairs of electron di antara these 2 oxygen atoms. So this will be the Lewis dot symbol, okay, for the formation of the 2 covalent bonding just now. So to represent this molecule in the form of Lewis structure, the 2 pairs covalent bonding shared just now can be represented by drawing these 2 single lines. Okay, so these 2 single lines ini kita panggil sebagai double bond. So in this double bond, kita ada sharing of electron sebanyak berapa banyak? 2 elektron dan juga 2 elektron. So total electron shared adalah sebanyak 4 elektron ataupun 2 pasang. And in the next example, kita ada oxygen, carbon and oxygen. So again, this oxygen has 6 valence electron, carbon has 4, then oxygen has 6. So the first oxygen needs another 2 electrons to achieve octet, carbon needs another 4, and oxygen needs another 2. Okay, so apa yang kita boleh buat adalah, so this oxygen akan share its 2 valence electron dengan 2 valence of carbon, and the other oxygen as well akan share its 2 valence dengan 2 valence of carbon. So di sini you boleh nampak, okay, kita ada sharing of 1 pair, 2 pair, 1 pair and 2 pair di sini. So untuk carbon, kita akan ada carbon and oxygen. The first carbon and oxygen, okay, akan melibatkan sharing of 2 pairs of electron, and di antara carbon dengan the next oxygen sebelah kanan pun akan melibatkan sharing of 2 electrons. So by sharing these electrons, you can check the Lewis dot symbol for the product. Oxygen has sebanyak 2, 4, 6, 8. So achieve octet already. Oxygen sebelah kanan akan having 2, 4, 6, 8. Pun mencapai octet, dan dan carbon di tengah akan mempunyai sebanyak 2, 4, 6, 8. So by sharing electrons, all atoms now sudah pun mencapai octet stability. So that is the main purpose of having chemical bonding between atoms. And these 2 pairs of electron between carbon and O can be represented by 2 lines here. Okay, sama juga yang sebelah kanan ni, 2 lines. Okay, so dalam this molecule carbon dioxide, kita boleh nampak ada presence of 2 double bonds. And the last one will be nitrogen. Okay, reaction between 2 nitrogen atoms. So in the first nitrogen, so nitrogen has 5 valence electrons. So in order to achieve octet, it needs another 3 electrons. Okay, sama juga nitrogen sebelah kanan. Okay, dia masih memerlukan sebanyak 3 elektron in order to achieve stable octet configuration. So what will happen adalah the first nitrogen here akan share its 3 valence electrons dengan nitrogen yang sebelah kanan. So yang kanan ini pun akan share sebanyak 3 valence elektronnya. So apa yang akan jadi di sini adalah sharing sebanyak 3 pasang elektron ini, okay, akan menghasilkan 3 covalent bonding. So di sini you can also represent this molecule, this bonding dengan menggunakan Lewis structure over here. So 3 pasang elektron shared di sini ataupun 3 covalent bonding yang baru terbentuk just now can be represented by 3 lines over here. So these 3 lines kita panggil sebagai triple covalent bond, di mana pada setiap satu bonding di sini akan mengandungi sebanyak 2 elektron. and you can check the octet stability untuk setiap atom. So nitrogen now dah pun ada sebanyak 2, 4, 6, 8 electron, and this nitrogen has 2, 4, 6, 8 electron as well. So by sharing electrons, each atom tadi sudah pun mencapai octet stability. To understand what is dative bond, let us see the comparison between covalent bond and dative bond. In normal covalent bond, each atom contribute 1 electron to form a single covalent bond. Okay, meaning that A with single electron akan share dengan B yang ada single electron as well. So sharing of this electron akan membentuk single covalent bonding. So ada berapa banyak elektron yang ada kongsi di sini? Kita ada sebanyak 1 pair of electron, satu daripada A dan satu daripada B. But in dative bonding, electron pair is supplied by one atom that has excess electron. Okay, electron pair iaitu 2 elektron lah. Okay, 2 elektron disumbangkan oleh satu atom sahaja yang mempunyai lebihan elektron, and it will share at the same time with another atom or ion yang having less ataupun no electron at all. So di sini contohnya adalah kita ada A. So A ni katakanlah elektron yang has excess electron. So maksudnya A ada sebanyak 2 electrons. And then B has no more electron. Okay, bila no more electron sepatutnya kita akan labelkan sebagai apa? Sebagai B+ lah. Okay, menunjukkan bahawa B ni has no electron at all. Okay, so apa yang jadi adalah A tend to give. Okay, give and share at the same time the electrons dengan B. So this action akan menyebabkan A now sharing its valence electrons dengan B. Okay, so in dative covalent bonding, kita boleh nampak bahawa kita ada satu atom yang having excess electron, which is here, dan satu lagi atom ataupun ion yang having less electron, okay, ataupun no electron at all, which is yang ini. Okay, tetapi still proses of sharing berlaku di antara A dan juga B. Okay, so elektron akan dikongsikan di sini. So this bonding yang kita panggil sebagai dative covalent bonding, kerana kedua-dua elektron pair bonding ini datangnya daripada satu atom yang mempunyai excess elektron dan dikongsi bersama satu atom or ion yang yang kekurangan elektron, sufficient ataupun deficient. So that is the main difference between covalent bond and dative covalent bond. In this example, we have ammonia molecule and H+ ion. So in the ammonia, we can see that nitrogen has extra lone pair electron. Okay, di situ. So N ada sebanyak satu pasang elektron iaitu 2 elektron. So in this case, nitrogen is able to donate a pair of electron to H+, kerana H+ kekurangan elektron. Okay, H+ has no more electron, okay, in its valence shell. So di sini bila N ada sepasang elektron, and N will donate the 2 electrons kepada hydrogen. So N is called as electron pair donor. Meanwhile, for the hydrogen plus ion, H+ is insufficient, kekurangan dengan electron. So H+ can accept electron from nitrogen. H+ can accept electron pair. Okay, terima sepasang elektron iaitu sebanyak 2 elektron daripada nitrogen. But please remember, hydrogen bukan sekadar accept saja, it will accept and share the electrons dengan nitrogen. So H+ is known as electron pair acceptor because dia akan terima elektron daripada nitrogen. So by having this process, maka kita akan dapatlah satu bonding yang kita panggil sebagai dative covalent bonding. So now you can see that nitrogen here has no more lone pair electron kerana sepasang elektron tersebut has been shared between the hydrogen atom over here. So to represent the formations of the dative bonding in this Lewis structure, kita akan gunakan this arrow. Okay, so this arrow menunjukkan apa? Menunjukkan ini adalah dative covalent bonding. And for electron pair donor, it must have at least a lone pair electron. Okay, ataupun mesti kena ada sekurang-kurangnya 2 elektron. Okay, untuk dia menjadi electron pair donor. And for electron pair acceptor, they must have at least one vacant orbital, satu orbital yang kosong ataupun no electrons at all. Okay, so no electrons at all ni contohnya macam hydrogen plus ini. Okay, so for this criteria, you must be able to identify lah, okay, in your structure nanti siapa yang akan boleh jadi electron pair donor dan siapa yang boleh diklasifikasikan sebagai electron pair acceptor. So bila ada sahaja 2 condition ini, maka barulah boleh berlakunya formations of dative covalent bonding. And here are the other examples of molecules or compounds yang boleh terbentuk, yang boleh mempunyai dative covalent bonding, okay, iaitu hydroxonium ion, H3O+, and H4Cl, okay, and the other 3 compounds ini. So now you can challenge yourself, okay, and try to draw the formations of the dative covalent bonding in the above molecules. So here we have ammonia molecules and BF3 molecules. So what you can see between these 2 molecules? Yes, we have lone pair on this nitrogen. But for boron here, we have nothing on the boron. So by having these extra electrons dalam bentuk lone pair pada nitrogen, ini membolehkan nitrogen ini to give this electron and share at the same time with this boron. So in this case, ammonia will be known as electron pair donor kerana nitrogen masih ada extra electron here, and boron in BF3 is known as electron pair acceptor kerana boron has no more electrons tapi dia masih ada vacant orbital yang kosong yang boleh menerima elektron. So here nitrogen will give this lone pair and share with boron at the same time. So ada 2 terms dekat sini, bagi dan share. So by doing that, maka akan terbentuklah, akan wujudlah dative covalent bonding di sini di antara nitrogen dan boron. So this dative bond consists of 2 electrons. Dari mana datangnya 2 elektron ini? Adakah from the sharing of electron daripada satu daripada boron, satu daripada nitrogen? The answer is no. This single bonding yang merujuk kepada dative bond ini datangnya, dua-dua elektron ini datangnya daripada nitrogen. Okay, so inilah uniknya dative covalent bond. Okay, kerana kedua-dua elektron comes from one atom sahaja. Okay, dan dikongsi bersama dengan atom yang mempunyai vacant orbital. Berbeza dengan covalent bonding yang biasa. Okay, contohnya, yang mana satu covalent bonding? So this is the example of normal covalent bonding. Okay, how many electrons in this single covalent bond? Kita ada sebanyak 2 electrons di sini. Okay, so 2 electrons ni kepunyaan siapa? Kepunyaan satu from nitrogen dan satu lagi daripada hydrogen. So sharing of 1 electrons each from nitrogen and hydrogen will form a normal covalent bonding. Tetapi sharing of all 2 electrons from one atom dengan another vacant orbital of this atom, maka we will get dative covalent bonding. So I hope by now you can see the difference between the normal covalent bonding and dative covalent bonding.